Okay, so I want to review some things or look at some things about polynomial functions. And again, I think a lot of this at one point probably was covered last year. But again, that doesn't necessarily mean you remember it. And so I'll kind of go through it as if you don't remember it. And that way, hopefully all of us will be on the same page. After we've finished watching these 2 videos or 3 videos, of these notes. So the first thing I want to talk about is the remainder theorem. And, we did some long division with rational functions, but we're going to do some long division and, in fact, some synthetic division as well when we have polynomials for this idea of to find remainders. Now, if I'm going to divide by a factor, I also need to make sure that I look at that factor as a binomial, but then I also want to think about, okay, if that is a factor, what is the x value that would make that factor equal to 0? And that value would be c. And so notice that c is the one singleton value that you plug into the function. So if I'm talking about c, it would have come from a factor of x minus c in the polynomial. Okay, and if you said, oh, it's x plus c, then your technical value of x would have been negative c, right? Because it's whatever makes it equal to 0. Okay, so it says if f of x is divided by this factor, then the remainder, if you were to have done long division, would have just been equivalent to whatever the value of that is. Okay, so what it's basically saying is that if you would have divided x minus 1 into this expression, x to the 5th minus 4x to the 4th plus 2x cubed minus 2x squared plus 6x minus 7, right? So if you were to do that and did all your long division and got to the very last line to get a remainder, you could have gotten there much quicker if all you're interested in is the remainder by figuring out what x would have, first of all, figure out what x that is. So that's 1. So if you would have just chosen c to be 1, you could have just evaluated f of 1 in the original function. And so if I do that, in other words, if I put 1 here, 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 and evaluate, whatever that value is would have been the remainder if I would have carried out the long division. So it's kind of nice. So that's 1 to the 5th power is 1. Oops, go back to a thinner line there. Minus 4 plus 2 minus 2 plus 6 minus 7. So the 2's cancel. That's negative 3. Plus 6 is 3. Minus 7 is negative 10. So as long as I did the arithmetic right, that would have been the remainder. Okay, and again, in a similar fashion, instead of doing this long division, because then again, that's an 11th degree polynomial, I could figure out my c value was negative 1 and simply evaluate f of negative 1. So that would be negative 3 times negative 1 to the 11th plus 4 times negative 1 to the 5th plus 2 times negative 1 minus 2. And again, this would be if you're only interested in finding that remainder. So that's negative 3 times negative 1 minus 4, because that would have been negative, minus 2 minus 2. So that's 3. Negative 4 minus 2 is negative 8. So I think it's negative 5. Okay, and again, one more just for good measure. The c value here is 2. So I could just find f of 2, which is 2 to the 7th minus 2 times 2 to the 6th plus 2 to the 5th minus 4 times 2 cubed plus 16 times 2 minus 1. There it is. Now, it looks a little bit intimidating, but I hope you recognize that there's a lot of opposites here. 2 to the 7th, and that's technically a 2 to the 7th. 2 to the 5th, and this is technically 2 to the 5th, since 4 is 2 squared. So that's a big 0. So I get 32 minus 11, which is equal to 21. Okay, so that would be just if it's equal. I'm sorry, that would be just if it's looking for the remainder. Now, Why would we be looking for the remainder? Because we'd like the remainder to be 0. Because if we can find a remainder to be 0, then we know that it's a factor, right? And so that's the whole point, that if you have a function that gives you 0, or if you know the factor divides evenly, then you know, like the other one, then you know the remainder is either 0 or you know it's a factor. So this if and only if, that goes both ways. So you could start at either end of this theorem and the other one applies, like the other direction implies. So our job is to think about, okay, if I want a remainder of 0, I'm sorry, if I want to know it factors evenly, then I know I want a remainder of 0. So instead of actually having to do the long division, I can just look for that remainder. So I'm looking for this, I'm looking for this. I want to know, are either of them or are both of them factors? So in trying to find that factor, oops, go to my pen. So in trying to find that factor, I'm going to choose 8 and I'm going to choose -3. And if I can get those to line up and cancel, then I know they're factors. So first you could try I guess it's g of 8, and then try g of -3. Right, so if you put an 8 and you do the arithmetic, and for this exercise, I'm okay if you go to your calculator, that's fine. I'm going to tell you, by inspection, 8 to the third power is going to be way too big, to figure out if that's a factor or not. And then -3 cubed, so that's -3 cubed minus 9 times -3 squared plus 2 times -3 plus 48, so that's -27. This would be minus 81, and then this is minus, oh, I take that back in the other one. I wonder if that is true. Minus 6 plus 48. So this one definitely does not work. This one up here, 8 cubed, I guess I was thinking of 8 to the 4th power. So we have 8 cubed, which is 512, minus 9 times 64, which is equal to 576. Oh, this one's going to work out. I see, and correct it. Plus 16 plus 48, because 16 and 48 is going to give you 64. And that's exactly, this is -64 plus 64 equals 0. Oh, so look at that. Initially, I thought it was wrong, but it is right. So this one gives me this one gives me 0. So I know that this is definitely a factor. This one does not give me 0, so it's not a factor. Okay. Now, I think my point of this arithmetic is hard, and especially when you have factors that are large, it's hard to do without a calculator. So perhaps it might be worth our time to review synthetic division. Synthetic division is really, really quick and really, really easy, and it doesn't involve a whole lot of large computations. So let's review synthetic division. Here's how synthetic division works. And again, I think it's really, really helpful and easy to do once you know how it works. So pick off your coefficients first. So the coefficients were 1, -9, 2, and 48. And make sure you put them in order, but then obviously it doesn't matter. You're not writing the cubes or the squares or x's, or you're just keeping track in order. And then remember, we're trying to see, is x minus 8 a factor? So we're going to choose 8 as the 0, or as like the potential c value that would work. So you drop down your first coefficient. You always do that. Now, you're going to multiply this number by this value. So 8 times 1 is 8. And here's the big difference between synthetic division and long division. You are adding. So then -9 plus 8 is -1. Then you multiply. 8 times -1 is -8. You add. That's -6. 8 times -6 is -48, and you add and you get 0, and that's the 0 that I want. So if you get 0 here, that means this right here was your c value that would have fit. So c equals 8. Yes, that gives you a remainder of 0. So that means x minus 8 is in fact a factor. Okay, now how do you read what's left over? And then I'll go with that x plus 3 again. How do I read this? Well, this means that now that I was a cube, now I'm 1 degree less. This tells me I have 1x squared minus x minus 6. And then remember, because I knew this was a 0, that I would have had an x minus 8 as a factor. So that's what I've got as a result if I would have done long division. Okay. Now let's do synthetic divisions practice one more time. I'm sorry, and show that x plus 3 is not a factor. So go back and you can write down. Oops, a little bit there. There it is. Good. Your coefficients again. Pick a different color. Go brown. 1, -9, 2, and 48. And then we want to try -3 because that would be our C value. So we carry this down, bring the 1, we multiply and add. So -3 times 1 is -3. Don't forget to add. That's -12. -3 times -12 is 36. Don't forget to add. That's 38. -3 times 38 is -4. Carry my 2, 114. And then when I add, it's not 0, right? So I know that it doesn't divide evenly. Okay, so good reminder on synthetic division. And in the next video, we'll review how to find the potential rational roots so that we can start logically, quote unquote, guessing what our solutions are to help reduce our polynomial to something that is factorable.